Hi, everybody. Welcome to another episode of the HOSS Talks FOSS. I'm the HOSS, head of open source strategy here at Percona, Matt Yonkovit. And today I am here with Yahav Biran from AWS. How are you today, Yahav?
Thank you. I'm doing great. It's Monday.
It's Monday. That's right. It's Monday. And right now, it always happens when I record something. Someone decides to do work outside. So right now, my neighbor is running the lawnmower and he's trimming some bushes and he's doing all kinds of other stuff. So I'm like, ooh. So hopefully that doesn't get picked up on the mic. But if it's going to happen, it's going to happen during one of my recordings here. But that's okay. So Yahav's going to be joining us at Percona Live, and I wanted to sit down and talk to him about some of the things that he's done, talk to him about his career, where he got started, and what interests him. So maybe you can just give us a little introduction to yourself.
Okay. So thank you for having me. I am a solutions architect. I'm in the last 3 years, I've been a solutions architect in AWS. I was supporting a DNB customer, digital native businesses customers, as well as gaming customers. Now, the reason that I like to support these two types of customers because that they are these two personas or customers type offer you the things that I'm very interested, which is large scale of everything, large scale database, large scale compute, and that is the challenge that I like to usually to solve. Before that, I was working in a large gaming company, was a product manager, and before that, working for Microsoft as a product manager in the compute. So the way that I like to see myself is that I am a generalist that like to specialize in everything.
Ah, yes. Well, yeah, I mean, and that's great to get your hands into a lot of different activities. I'm sure that that's something that, a lot of us appreciate, because getting stuck just doing one thing over and over again can be a little mundane. So having the ability to float around is often a good thing. Now, you mentioned some focus on gaming, and I wanted to talk to you a little bit about that, because that's a very interesting topic. I've given a couple talks on that. I've actually published a couple articles in a few places on the gaming industry and databases as a whole. And it's interesting. So my experience in that space is you tend to have kind of a twofold problem. And I'm curious if you've seen this as well, where you've got not only the game itself that needs its infrastructure and its data related activities, but you also have all of the ancillary pieces that they might outsource or they might purchase or license from someone else, whether it's matchmaking services, whether it's chat, whether it's something else. And all of them have their own databases, and all of them have a potential point of failure. And I found that testing from a gaming perspective, they tend to do a lot on the core game, but a lot of those ancillary services, they tend to undertest. And I don't know if you've experienced that as well.
Yes, absolutely. Well, that's exactly one of the problems, the architectural problems that customers usually have when they are designing workloads on the client, games workloads, I should say, or gaming workloads. And it's exactly what you said, because the critical path of the game is you and I are just shooting or building things, right? But then if we want to make a microtransaction or making other things that are not on the critical path, it is usually delegated by other services to other services, and that by design and architecture, it is decoupled, right, from the game, and that's sometimes neglected in the design. It's something that the reason that it's also neglected is because that it's usually not just that it's not on the critical path, but it's also a part that is not the most important part of the game, because it's, if you think about it, those things are just transactional, like any transactions, right?
Yeah.
Purchasing loot or any other things. I want to mention something that in previous Percona, in 2020, I presented a talk that helps games customers to detect fraud in gaming. So with machine learning. So what we've done, we basically looked at all the data set, include the game events and the microtransaction. We combined all of them. We helped to build a model, right? A machine learning model, and help the game live ops team to go and access this machine learning inferences through MySQL or Postgres, right? So you can actually run SQL functions that will on the back end going to call machine learning models to detect fraud.
Yeah, and we'll put a link in the video here just so people can check that out, because I believe that's recorded and on our YouTube channel for those who are interested. Or we'll put a link to the slides because we'll have those from that Percona Live. I do remember that talk as well. And I think that's a really interesting, segue, because I think that, as we talk about, the need for databases in the gaming industry, it's always growing. If it's not the actual critical services or even the ancillary services, it's the metadata, it's the auditing, it's the, trying to find those problems. And I think that's an interesting space because, gaming is one of the spaces where you could have one game has dozens, if not even hundreds, of different workloads that it needs to support from an infrastructure perspective. It's not just an OLTP. It's not just a, in-memory, engine. It's not just a, analytics engine. It's all combined into one. And a lot of times, if one of those pieces breaks, it then causes cascading impacts.
Right. And this is why you would like to design your system in a resilient way so it's not going to be impacted. There is another pattern that I'm suggesting is that when you basically have, let's say that you have a large, let's try to think about a large scale game, right, that spans across many regions, right? And it stores its state somewhere in some database, right? So you need to make sure that its state will propagate across all the regions, right? So, and it's not just from resiliency perspective. You want that the game will be more performant, right? You don't want to write to an Asia Pacific when the player is playing in Virginia, right, or in the East Coast. I'm sorry. Right, so things like that. So you want to think about the architectural aspects to spread it nicely for both performance and resiliency, and that needs to be applied across not just the database but also on the compute, right? And all of those, all these two layers needs to be decoupled, right? So they will not experience the cascading effect that you just mentioned.
Yeah, and I think that one of the things that I have seen, especially from the problems that occur like week 0 or week 1 of a game launch, or early on, those architectural issues that weren't flushed out or people didn't think through the design or the implications, those tend to bubble up very quickly because the traffic ramps up so fast. Right. And that's when you start to experience that pain. And unfortunately, if it's a design issue, that becomes a more difficult issue to fix. I mean, you can add additional hardware fairly quickly. You can, grow instance sizes. Maybe if you've added the ability to scale a certain way and add nodes, that will, you can add horizontally as well. But if you've designed the schema or the infrastructure a little wonky, maybe you haven't built in all of the concepts to do that scale quickly, then that really can hinder your launch.
Yeah, absolutely. So if you think about it from compute perspective, that's easy. I think it's easy. It's just because by nature the compute is stateless. So you just need to think about spinning up and down resources to address player needs. But what you mention now is much more critical on the database side, right? You want to make sure that the players will have the right performance. They will have the right reaction from the system on time. And then there is another thing, right? You mentioned that in the first 2 weeks things ramping up really, really fast. But what if the game is not successful, right? What happened if after 2 weeks everything going down? So you also want to react faster and not spend too much time in modifying those things when things are trending down. So the elasticity is becoming a critical path, especially for games, right? Because it's very trendy. It's not like a bank, right? That will have a stable patterns, and games are very emotional workload.
Yeah.
And
Yeah.
so we need to think about those things as well when we design games.
Yeah, events and other things, new patches, updates, add-ons can cause those spikes at any one given time. And once you launch, sometimes you have to support for a really long time, and that means that over time you will see not only the increase but the decrease. Hopefully, if you're successful, it's a slow decrease, but eventually it does happen. But speaking of design, we just went through COVID, the last couple of years, which meant that there were a lot more people online, a lot more people looking for alternative ways to escape, which means that from a gaming perspective, from a streaming perspective, from an online perspective, the traffic went ballistic. It went crazy. Everyone lived on the internet for the last few years. I mean, we lived on the internet before, but we took advantage of living on the internet the last few years. And your talk at Percona Live is talking about how that spike in traffic, how the additional workload on Postgres databases started to manifest, especially with larger data sets, some locking contention. And that was something that you started to see and you worked with others to help address. Maybe talk to us a little bit about what you saw there as the traffic started to ramp up, as those data sizes started to get bigger.
Yes, so it is a combination of two things. The first one is what you mentioned, right? People just spend more time at home and they were doing things from home. So instead of going to order something, they were ordering things online, right? So that's one thing. But the second part is that we in AWS, in Aurora specifically, we build a platform that allows you to store a lot of data, right? A lot of data. And when I'm saying a lot of data, I'm talking about tens up to hundreds, actually. The official limit is up to 120 or 130 terabytes of data set of your Postgres, which is unheard. Usually it does not meant to be the hundreds of terabytes does not needs to be stored in the hot path of the application, but theoretically you can do that, and then the combination of these two started to manifest in locks that we haven't seen in Postgres. As a matter of fact, when we were troubleshooting the customer issues, we had very little reference in the Postgres community to talk about these symptoms. And this is one of the reasons that my partner Sami and myself, who is a database engineer, chose to experiment that, to investigate that, and to blog about it and present it here.
Yeah, that's great. Yeah, and I think that this is one of the interesting patterns in databases that I think application developers might take for granted, especially now, maybe not before, but I've seen as people are moving faster to get applications out to, do new releases, they tend to try and treat databases as a commodity. They do less design work, and so they rely more on sometimes tools or ORMs or other things, and so it works, and that checks the box for them. But then it doesn't really necessarily work at scale. And it's like one of those problems that it's just bubbling underneath the surface, and when it reaches a point where the underlying structure can't handle it anymore, it bursts, and it causes quite significant slowdowns. And unfortunately, right now, fortunately or unfortunately, we don't have a lot of patience for slowdowns, on the web or in games or on applications. We kind of expect things just to work, and we want it now, right? So even a few milliseconds or 100 milliseconds or a few seconds, it's going to cause a bad user experience, and that can really hinder a company's overall value and their perception by the community.
Yeah, and you're absolutely right. This is exactly what we've seen. You mentioned the ORM, right? The customers are trying, they want to start fast, right? They want to start fast, and they just go with some naive approach. They focus on their business, right? And they just want to make sure that the ordering system is at place, or whatever the business logic is. And they assume many things, or basically delegate that to the platform, and the platform as the ORM, but also to the infrastructure, which is AWS or whatever your favorite cloud is. And then when they hit this spike, then they are crying for help, and rightfully. Now, there was another talk that I gave in last reInvent in Vegas, that talks about that, how you could just, before you jump into this naive design, which is good because it's by design. You want to start fast. You don't want to think about all your schema and how the referential integrity will work, etc., because you don't know those things at this stage. So the talk that I gave in reInvent actually give you 4 tips that just think about those things, right? Before you go and write your application, make some assumption, and then you just go, and you're going to be safe when you're going to hit the terabyte mark in the hot data set. And now that I think about it, maybe it's going to be an interesting talk for the next Percona.
Oh, yeah, definitely. Because honestly, I think that's one of the big areas is lack of design skills or understanding, the choices you make early on impact you. Like I said, it's actually really infinitely more difficult to make design changes to your application after it's live than it is to add additional infrastructure, to add additional nodes, to scale up, to scale out. Those are things that we've done as an industry a good job in providing you tools to do some of that scale. I mean, the Amazon interface for adding nodes or replicas, it's very straightforward and simple, but your application has to support that. So the design is where the focus area needs to be in the future in order to ensure that you have great scalability.
Yeah, and the canonical example, so it's all spot on. And the canonical example of what we just discussed is partitioning, right? So you start a new application, right? And you start with the ORM, right? And you just define your schema, and you just go and start building, right? You launch the application, it does lots of insert, does a lot of updates, your database is growing, and now what? Now you need to partition your database to reduce the hot data set. And doing that when you have data is an open heart surgery, right? But if you do it before, it's just a modification, like a true modification in the ORM spec, and that's it, and you're done. And that is thanks to Postgres, right? The Postgres engine evolved a lot in its support for partitioning, and this is another topic that I'm investigating right now with my buddy Sami that is going to present with me. And that is what we want to do. We want people to we want to add these partitioning things and other patterns to be the naive approach. When you start, you just put it there, right? It's just there, and you don't have to go through this open heart surgery and make these heavy changes when you grow. And if you didn't hit the growth that you wanted, it's not a big deal. You're not gonna suffer from the new naive approach, which is just partition your database.
Indeed, yeah. I mean, I think that's a critically big mistake that people make is they don't think up front. And I think it's great advice that you need to think through some of the implications early on to avoid the problems later on. Now, changing gears just a little bit, one of the other things that I know that you have some passion for is contributing and working within the Kubernetes community. And going hand in hand with, the large scale applications is also, that kind of building out the ability for applications, not just the databases, to scale out. And a lot of people have been using Kubernetes and microservices as kind of the de facto standard as you're designing new applications to roll out the ability to scale those applications. So I'm curious, what sort of work are you doing in the community? And maybe tell us a little bit about some of the things that are going on there.
Right. So if we move up a little bit to the application level, the AWS and Kubernetes allow you to spin up as much compute you want or didn't even wish to run. But with that comes a problem, right? It comes, there is an increasing cognitive load to understand how to operate all of that, right? And how to operate and manage it. And gonna give you an example, right? Kubernetes is a blessing and a curse, right? It allows you to do to define all kinds of operators. I think Percona has an operator for their stateful application as well, but it offers you lots of flexibility. Now, this offering is manifested in many configuration files and all things that's supposed to help you to go and deploy that. Helm is what is the product that is the service that I'm contributing it. I'm looking at patterns that customers are adopting, and they are facing the challenges that they are facing on how to deploy complex application that includes all kinds of primitives, Kubernetes primitives, but also their operators, right? And deploy it in an easy way and help them to operate it and manage it more effectively. So my main contribution is around looking at patterns from customers and translate them into Helm charts that basically make the DevOps, the customer DevOps life easier.
Yeah, and I think that's super critical. I mean, as we talk about the shift in design paradigm, so many companies now are all about enabling developers, and developers are all about building their individual components, reusing what's out there. You end up with a tapestry of many different technologies across many different environments, across many different, implementations, and it's getting more and more complex. So anything that we can do to kind of rein in the complexity, give some tools to make it a little simpler is critical. Because there's just so much. I mean, I've talked to people, and they might have, an application or a set of applications that has 7-8 different databases that are part of the infrastructure. They might have a couple different development stacks within that same infrastructure. They might have all kinds of microservices, dozens, hundreds even, and they all do little different things. They all have different little requirements. So it's really that shift from managing just a few servers to managing hundreds or even thousands of servers. I mean, and I think that shift requires a lot more focus on the ease of use and on what you can do. And I think, Helm and Kubernetes, definitely go hand in hand in helping to kind of reduce that craziness.
Yes, servers is one dimension. I would say that this is the X dimension. But the Y dimension is the complexity, right? Microservices take the monolith and decompose it, right? Every component in the microservice has its own config, has its own binaries, because you separate them. And that is that makes that's the cognitive load that I was referencing before, right? So the complexity is multidimensional, and Helm specifically help you to go and take all the abstraction that you made, put them in one chart or two, and just hand it to the DevOps team to go and operate that, instead of going and figuring 7,000 config maps, etc., in your Git repository.
Yeah. No, I mean, reducing that complexity is so important, so critical.
Yeah.
Well, Yahav, I want to thank you for joining me today. This has been a great conversation. I just love talking tech. I love talking about database stuff. I love talking about the industry. So this has been spectacular. I hope that those who are listening will join us at Percona Live. Yahav's going to be there, and we'll be able to get together, maybe have a drink, or chat a little bit more. But love to hear about the work that you have uncovered in debugging and kind of unblocking some of those low-level locks in Postgres.
Perfect. Yes, thanks for having me, and I really, really looking forward to meet all of you. Please come by, even if you don't have the time to watch the to listen into my topic. I would love to hear about issues that you have, and if I can just take some information and build some fun things for next Percona, would be great.
Awesome. All right, thank you.
Bye-bye. Thank you, Matt. Bye-bye.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.